Hello friends, you are welcome to Success Hub Media. We are currently working on the Mathematics Made Easy, where we learn the secrets of mathematics. And this is part 4 of this series. So in this part 4, we'll start learning how to solve equations. That is why it is termed solving equations. If you are new to this channel, do well to like, subscribe, and hit the bell icon so that you'll be notified automatically whenever a new video is released. Note that subscription is free. Without wasting much time, let's have a quick recap of our last lesson, which was lesson 3. In lesson 3, we learned 3 important things, which the understanding of the phrase coefficient of x. We learned when to divide both sides by the coefficient of x, and we also learned how to divide both sides by the coefficient of x. Please note that this knowledge here in part 3 is a prerequisite for you to understanding how to solve mathematical related problems, because this is where you will always end when solving mathematics. So I strongly recommend you go and watch this video. As you are watching the video, pause each pages and take notes. Okay, so we'll be moving to the lesson of the day. We're moving to the lesson of the day, which is collecting like terms. That's what we'll be discussing today. In order for you to collect like terms, you first of all have to understand what like terms are. What are like terms? You then need to understand when to collect like terms and also understand how to collect like terms. So we'll start with the first scope item, which is what are like terms. So without speaking much grammar, in mathematics, like terms are terms that have the same variables raised to the same power, although they can have different coefficients. By the time we take 1 or 2 examples, you have a very clear understanding of what this grammar here is all about. So let's look at this example 1, where we have 2x plus 3 equals to 5x plus 1. We said like terms are terms that have the same variables. If you look at these 2x now, the alphabet is referred to as the variable. So we can see that 2x has the variable x, 5x has the variable x, and they are raised to the what? The same power. The power here of x is 1. We did not write the 1 here because we like making 1 to be invisible in mathematics, okay? So it simply means this is 2x raised to power 1 and this is 5x raised to power 1. So they are like terms. And also note that in mathematics, when numbers are written on their own like this, we refer to them as constants. So we can also see the constant as like terms. So that when we are collecting like terms, we will treat the constants as being brothers that have to be brought together. All right. So let's take a look. Okay, so we said the like terms here are 2x and 5x. Then we also said note that numbers that stand alone are called constants. They can also be referred to as like terms, which is just the 3 and 1 I've just explained. And also the constants in the above example are 3 and 1. They can also be referred to as like terms. So I always advise you make pauses of each page like this. Take notes before moving to the next page. All right. So taking a look at the second example, we have m minus 4 equals to 7 plus 8m. Take note that although we've written m here, there is an invisible 1 here. So this is the same thing as 1m. We've already established that in our lesson 1 and 2 of Mathematics Made Easy. So it simply means that this 1m and this 8m, they are like terms because they have the same variable m and they are raised to power 1 and 1. So they are like terms. Minus 4 and 7 are ordinary numbers, so we can refer to them as constants. They are also like terms. Take note, I did not just say 4, I said minus 4. That is because this minus belongs to this 4, and it is very important to take note of it, as it will help you in our journey of mathematics. All right, so the like terms here are m and 8. The constants in the above examples are minus 4 and 7. They can also be referred to as like terms. Okay, so now the question now is when to collect like terms. We are moving to the second scope item. You collect like terms when they are far away from themselves with the purpose of operating them together. let's take a look at example 1, where we have 2m plus 3 equals to 11. Now, if we are given this equation to solve, the first thing that should come to our mind is collecting like terms, so that every brother will go, every term will go and marry up with his own brother. We've already established that a number standing on its own is a constant. So 3 is a constant, plus 3 is a constant, 11 is a constant. So in order for you to collect like terms, you have to move constants to constants and variables to their variables. Okay, so like in this case now, collect like terms. Okay, so with this same 2m we have here, this is the 2m, this is our equal sign, this is it. 11 was on the right hand side, it is still maintaining its position. So we have moved this plus 3 to from the left hand side of this equation. I call this left hand side because this equality is separating this left side and this right side. So we have moved this plus 3 from this side of the equation from the left hand side to the right hand side. And take note, when you are collecting like terms, whenever a man crosses this river of equality, it changes to a woman. Whenever a woman crosses this river of equality, it changes to a man. In this case, plus is a man, plus 3 is a man. Always take note that whatever sign, be plus or minus, that is in front of a number, that is its own sign. So plus 3 is crossing to the other side of the river, which is the right hand side. It will have to change to what? Minus 3. That is why we have minus 3 here. So we now have 2m equals to 11 minus 3. Alright, so 11 minus 3 leaves us with 8. So we have 2m equals to 8. As you can see, we have come back to our last lesson, which was lesson 3, where we learned how to divide both sides by the coefficient of x. And we also established in that lesson that x could be any other alphabet. We just use x because x is very popular in mathematics, okay? Now, so what you do here is what we've learned in our previous class. So I won't dwell on that. So we'll just move forward. So we'll have to what? Divide both sides by the coefficient of m. So dividing both sides by the coefficient of m, which is 2, we'll have 2m divided by 2 equals to 8 divided by 2. So when 2 cancels 2, we have 1m. When 2 goes into 8, we have 4. So our answer is 4. Let's take a look at another example. We have 3x minus 4 equals to 17. What do? We collect like terms so that brother will go and marry up with his own brother. And we've already established, we say we collect like terms, we've already established that when the sign of this plus is this minus here. When a woman crosses this river of equality, it changes to a man, or she changes to a man rather. Now, when minus 4 crosses over to come and marry up with his brother on this left hand side, on this side of the river, it will change to what? Plus 4. Thank you. Alright, so we'll have 3x equals to 17 plus 4. Okay, so 3x is equals to 17 plus 4 will leave us with 21. So we have come back to this stage in mathematics that we learned in part 3 again. So what do? We divide both sides by the coefficient of x. We divide both sides by the coefficient of x, which is 3. So dividing the left and right hand side by 3 will leave us with x being 7, because 3 in 21 is what? 7. Let's take a look at another example. We have example 3. We have 5x minus 4 equals to 18 plus 3x. The same rule applies. When you have an equation like this and you have to solve the equation, you take brother, you marry up brother to his own brother. And take note, we always prefer having the variables to our left hand side and moving the constants to the right hand side. So if we like having our variables, which is x in this case, at our left hand side, it simply means instead of us to move this 5x to the right hand side, we prefer moving this 3x to the left hand side because we prefer having variables at the left hand side. That is what is preferable in mathematics, okay? So if that is the case, it simply means we have to bring plus 3x to come and marry up with 5x. 18 is on the right hand side. It is already where we want it to be, so there is no point moving 18. Rather, it is minus 4 that will have to move to the right hand side to marry up with 18. So if that is the case, we'll start by writing the mathematical jargon, which is collect like terms, okay? So what do? Just as we've established that we already had 5x here, we are moving plus 3x to this other side, it has become minus 3x. It is very important to take note of the sign. Okay, this river of equality is still this river of equality we have here. This 18 is still the 18 we have here. So minus 4 has crossed from the left hand side of the river to the right hand side of the river. It is now plus 4. Very good. We've already learned how to subtract similar items in lesson 1. So if you haven't learned part 1, I would strongly recommend you check my playlist. Okay, so 5x minus 3x is the same thing as saying you could just liken, you could liken x to be anything. Let's say apples. You could just say 5 apples minus 3 apples to give you 2 apples. So that's why you have 2x here equals to 22. We've already learned how to divide both sides by the coefficient of x. So we divide both sides by the coefficient of x. On doing that, we'll have 2 dividing the left hand side and the right hand side, and we'll have x being equals to 11. Now let's take a look at another example. Very important. We have 19 equals to 5 plus 2x, and we need to solve for x. Now, we have already established that we prefer having our constants at the left hand side, our variables at the left hand side and our constants at the right hand side. So what I would do, the first thing I would recommend you do here is to flip the equation around. When you say something is when you say a is equals to b, simply means you could also say b is equals to a. So it simply means that when you say 19 is equals to 5 plus 2x, you could also write it as, by flipping the equation around, you could also write it as 5x equals to 19. Take note, we haven't done anything, we just flipped the equation around. You could also want to ask that, why is the plus 2x not changing to minus 2x? No, it will not change yet because we've only flipped the equation around. We haven't collected like terms. It's like saying a is equals to b, so you could also say b is equals to a. Very good. Now we are here. 5 plus 2x equals to 19. What do we do now? We collect like terms so that 5 can marry up with his brother. So we will now be left with plus 2x here, plus 2x. But we did not write this plus again because this is the first thing we are writing. When we are writing plus as the first thing, we prefer making it invisible. This equality is what we have here. This 19 is what we have here. So this 5 here has invisible plus. We've already established that in lesson 1. So when this plus 5 crosses over to this side, it becomes minus 5. So we now have 2x. 2x equals to 19 minus 5 will leave us with 14. So what do we do at this stage? You can see that we are still coming back to this stage in mathematics. It's an important step that you must learn. Okay, so what do? We divide both sides by the coefficient of x, which we've already established. So by dividing both sides by the coefficient of x, which is 2, we'll have x leaving us with 7. Okay, here's an assignment for you. Solve the following equations. We have a 2y minus 4 equals to 16. Number 2, we have minus 3 plus 4m equals to 13. And lastly, we have 5n minus 2 equals to 13. So you can leave your answers in the comment section. And if you have any challenge in this lecture so far, you can let me know you're having challenge in the comment section. And if there is any topic in mathematics that you would like me to make a video on, you can also feel free to comment in the comment section. So remember to like, subscribe, and hit the notification icon so that you'll be notified for future lessons. Thank you.